I was going to show off my electrolyzer, but I don't think I have a good spot for it, so we'll have to do that after the show's over. And Dale, thanks for the talk earlier. I think what we're going to talk about now, specifically, is what we do with some of those renewable electrons to apply to the industries like shipping, chemicals, aviation that can't defossilize. They need hydrocarbons. And if we're going to make hydrocarbons, Nobel laureate George Olah proposed that we use the methanol economy, which is to take the most versatile chemical on Earth, one that is energy dense and can make the cleanest fuel on Earth, and figure out a way to make it cheaply. Now, that is kind of the core of what we're going to talk about today, because we are creating breakthrough climate technology that brings the cost of green methanol down precipitously. Now, this is real data that you're going to see on the screen. We've been around for about 2.5 years. We've spoken to customers. There are commercial tipping points for the adoption of green methanol. What we know is that our customers want green molecules. They're not averse to it. They're averse to the cost of green molecules. Now, today, green methanol costs about $1,600 a ton. There's very few people who can afford that. In 2050, if you assume zero-cost hydrogen-free energy, it still costs about $800 a ton, most of it in capital cost. Now, what we're producing is electrolyzers, what you'll see over here on the podium, that actually make methanol directly out of CO2 and water. Skipping green hydrogen, skipping syngas, about 4 times more capital efficient. So we can access parts of the market that nobody else can access, parts of the market that are left behind in the energy transition. Now, where is methanol used in these sectors? Well, traditionally in the chemicals world, methanol is turned into solvents, thermoplastics, fragrances, hair care, cosmetics. If it's in the chemicals world, methanol is probably touching it. Methanol is also burned directly as a fuel in ships, and you can turn it into jet fuel. Methanol to jet process can turn methanol directly into Jet A. Now, that's a very big market opportunity, big numbers all across the board, but importantly, it's 11% of global emissions that has no other path to decarbonizing. They need the energy density of the hydrocarbons, or they need the material properties of the carbon atom. So what have we created? Well, here at Yale, my co-founder and CTO, Dr. Connor Rooney, spent about 6 years in the Energy Science Institute working on catalysts. This is a catalyst breakthrough. Now, the reactor, when you look at it later, you're going to see that it's basically a hydrogen PEM electrolyzer. But there is a catch. There's a catalyst sitting on the cathode that lightly binds to CO2. Now, when water creates protons and electrons and the protons cross through a membrane, there's CO2 to bind to. So effectively what we do is we use electricity to break bonds, rearrange them directly into methanol. This is the only catalyst that can make methanol in this process, and it cuts out about 70% of the cost of making e-methanol. Now, I know this is where everybody glazes over a little bit, but traditionally, green methanol is made using electrolyzers because you need hydrogen. So first, they use electrolyzers to make hydrogen. Then they make syngas, combining CO2 and hydrogen under really high temperature. And in a third reactor, they make green methanol under really high pressure. Now, what we've done is combine all 3 steps into one, all in an electrolyzer using this breakthrough catalyst, leading to about 3 to 4 times the cost, or the capital efficiency, and 70% of the cost reductions. And this isn't science fiction. The reason I brought the electrolyzer is because there's actual work being done here. We've existed for 2.5 years. We build electrolyzers. We've been doing this in total for about 7 years, including Connor's work here at Yale. And we're getting ready to build the first plant. We've done all the requisite engineering. Our catalyst works. We're pushing about 1,000 hours of operation in our reactors. Now, I have a minute left. There's a few slides. I'm definitely not going to finish all of them. But very importantly, it's a simple process, right? First, we buy CO2 from a carbon capture unit. We convert it to methanol on site. We distill it out from any analyte that's still in the mix, and we get chemical-grade methanol. There's a few competitors in the space. They all use the old process. They're using technology that hasn't been innovated on in over 100 years. We are engineers, scientists, and entrepreneurs who are building climate technologies to help build the future of energy. We have a lot of people supporting us. This is not just 3 people in a lab. We've got a community of folks helping us, including folks at Climate Haven and at Yale. And we built a team of 11 people representing the best knowledge in electrochemistry on Earth. We raised a seed round in July and are looking to raise a Series A soon. So stay tuned. Thank you very much for your time. Judges, I appreciate it. Thank you both.
Do we have questions from the judges?
Can you tell me about the challenges to scale up the current prototype to the next step?
Yeah, I mean, the first one is always cost, right? Now, we're talking, you're going to feel this later. It's a titanium block, effectively, that's been milled. There's a cost component. There are engineering problems associated with scaling up electrolyzers. The fuel cell and electrolyzer world has been doing this since the 70s. There are two big problems, flooding and mass transport. So how do you get CO2 to the catalyst? And how do you prevent water from hitting the catalyst? Solvable problems, not trivial. So you give us enough time and money, we'll certainly do it. But the trick is to move fast. Because Dale's point, we don't have endless amounts of time to be sitting in a lab. We're going to be scaling up the first electrolyzer by the end of the year, so I'm sure I'll have a better answer for you by then.
Is there anything the university can help you do to help scale faster?
Money, talent.
It's an impressive progress you've made. What is the business model that you're planning to implement over time?
Yeah, the ideal for anybody in my shoes would be to become an owner-operator. That's the most capital intensive. Now, the only reason I'm qualifying that is because the other end of the spectrum is the licensing route. Right now, I think the right way to approach this problem is to meet somewhere in the middle. You sell systems at first to people who like to become owner-operators, and then you become a developer and you start doing joint ventures. We're never going to take the most capital efficient, the most capital intensive process, becoming our own owner-operator. We're going to look for partners to help us scale up and take ownership stake in the plants that we build.
Let's assume you could scale up to your ambition tomorrow. What upstream and downstream infrastructure would you be relying on to enable that?
Renewable energy and CO2 carbon capture. I did run out of time. There's a lot more to that question. Manufacturing, financing partnerships, debt. There's a lot.
Thanks.
All right. Thank you to Oxylus Energy.